Okay, so this is Geometry Chapter 1, Section 7, midpoint distance in the coordinate plane. Midpoint and distance formulas. Okay, so the first formula they give us is the midpoint formula. And the midpoint formula basically deals with going in one direction, one line. So it's going to be something on the number line. And the midpoint is going to be in the middle. So the way that works is we have the book gives us some segment AB. So it's on a number line, and that number line can go in either direction. Looks good. It can go in either direction. So we have a number line. We have a point A. We have a point B. So remember in the previous lesson we said that the lowercase coordinates or the lowercase letters mean the coordinates. So label of it is uppercase A, label is uppercase B, but the coordinates lowercase letters. What the midpoint formula says, we have some coordinate in the middle, and we call that the midpoint, such that this midpoint cuts both of these guys in half, right? So A to M would be equal to M to B, or we can say A to M is congruent to M to B. Remember with congruency we can put the segments up. And there's an equation for that. And the equation is going to be adding up the coordinates of the first point plus the coordinates of the second point, and we're dividing it by 2. Adding the coordinates of the first point plus the coordinates of the second point and dividing it by 2. That's doing the midpoint on a number line. Then they give us another equation, which is a midpoint on the coordinate plane, which is just like the midpoint on the number line, but now instead of having one coordinate, we have 2, one going up and one going down. So we'll make this more cut a coordinate. So we have it on a coordinate plane. And since we have it on a coordinate plane, I think of a coordinate plane as 2 number lines superimposed on together. So now we have a different situation. We still have an A, we still have a B, but now this A and this B have 2 coordinates, x1, y1, and x2, y2. x1 and y1 just means the first coordinate of x and the first coordinate of y. x2, y2 means the second coordinate of x or the second coordinate of y. They're interchangeable. The A could have been the x2, y2, or the B could have been the x1, y1. It just happens to be the one that I chose. So if you look at this midpoint formula up here, A plus B divided by 2, well, we're going to do that twice. One for the x coordinate and one for the y coordinate. So when we talk about the midpoint of this one, we say that the midpoint is going to be the x plus each other divided by 2 for the x coordinate and the y's plus each other to get the midpoint of the y coordinate. That will get us our midpoints of the ordered pair. So this is the midpoint of an ordered pair on a coordinate plane. And the other one is the midpoint on a number line. The book says they're like the averages of the points, which is just to add them up and divide them by 2. So let's do an example of this. We have for got it 1a, they say, okay, we have a number line from -12 to +4. What's the midpoint? -12. -11. -10. 9. Let's see if this is going to actually happen. 3. -2. -1. 0. 1. 2. 3. 4. Holy moly, I made it work. We got one at 4 and one at -12. Had to squinch them together though. So, the way that this works, the midpoint of JK, is going to be -12 plus 4 over 2. -12 and 4 gives me -8 over 2, and that gives me -4. So it would be -4. Now granted, my number line is not to scale, but if we was to count the distances, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So the distance from here to here is 8, and the distance from here to here is 8. Again, my number line is not to scale. So the midpoint would be -4. If we had a coordinate plane and we had to find the midpoint, we're given that R is 5, -10, and S is 3, 6. They want the midpoint. So find midpoint of RS. So remember, this is my x1, y1. This is my x2, y2. So when I add this, it's going to be 5 plus 3 over 2. And 6 plus -10 over 2. That's 8 over 2 and -4 over 2. So then the midpoint of RS is going to equal 4 and So when we talk about the midpoint of a segment, we have a number line. There's a segment. These guys are the endpoints. And then the guy in the middle is the midpoint. Well, we've just, in the previous example, solved a problem where we were looking for the midpoint given the two endpoints. You can also solve for one of the endpoints given the midpoint. So when they give us the midpoint and they ask us to find the other endpoint, we still use this equation. So I'm going to write it a little bit different. It's going to be the midpoint with the m for x of midpoint, y of midpoint. Actually, no, we'll just keep it the same. So here's how this works. Forgot at number 2, they say that the midpoint is 4 and -9. They give us an endpoint, and the endpoint is -3 and -5. Okay, so when we do the midpoint formula, the midpoint is going to equal the x1 plus x2 over 2, and then y1 plus y2 over 2. But remember, we're not given both endpoints to get to the midpoint. We're just given the midpoint. So the midpoint of x is going to go over here. The midpoint of y is going to go over here. Only one of the x's is going to go over here. Only one of the y's is going to go over here. So when we do this, we're going to do it for the x and the y separately. So for the x midpoint, it's going to be 4 equals -3 plus, I'm just going to put y over 2. And that's for the x midpoint. For the y midpoint, it's going to be -9 is equal to -5 plus y over 2. I'm going to multiply both sides by 2, so 2 times 4 is 8. 8 equals -3 plus y. 2 times -9 is -18. -18 equals -5 plus y. This should be x. I don't know why I wrote it. Or x, sorry. Add 3 to both sides, so the endpoint equals 11 of the x coordinate, and then I add 5 over here, and I get -13 equals the y coordinate of that endpoint. So the endpoint, the other endpoint, is going to be 11, -13. 11, -13. Alright, so this is a situation where they give you one endpoint and the midpoint. The previous scenario, the way that we did it before, they gave us 2 endpoints. So we would get 2 endpoints in the previous example. We're supposed to find the midpoint. In this example, we're given an endpoint, and in the midpoint we're told to find the other endpoint. All right, so then there's the distance formula. We have some segment on the number line, some point A, some point B. This has an x coordinate of x1. This has an x coordinate of x2 on the number line. This also has a coordinate of y1 and some other coordinate here. Let's call it y2. Alright. So when we find the distance formula, we're going to use the distance formula that we already discussed before, which was the absolute value of the difference between the two, x2 minus x1 absolute value. But it's going to be a little different. We're going to use the Pythagorean theorem. So here, to get the x difference, we're going to subtract the two x coordinates, x2 minus x1. For the y difference, we're going to subtract the y coordinates, y2 minus y1. This really looks like a triangle, right? And if you recall the Pythagorean theorem, Lord, who knows how to spell that word? The Pythagorean theorem states that c squared equals a squared plus b squared. Right? The sides of the triangle is equal to hypotenuse. So this part here is my c squared. This part here would be like my a squared. And this part here would be my b squared. So when I do the distance formula, right, so the distance is going to be equal to my a squared. No, doesn't matter which is which actually. Let's do this. Let's instead call this my a squared to be consistent with the book. It really doesn't matter which is which, but I do want to be consistent with the book. And this would be my b squared. But it's interchangeable. So when I do my distance formula, instead of writing a squared, we're going to write x minus x1 squared. Instead of writing b squared, we're going to write y squared minus y1, y2 minus y1 squared. If I wanted to use the Pythagorean theorem over here and solve for c, well, what's happening is c is being square, so I got to use the square root symbol to cancel all of that out. So then c would equal a squared plus b squared square rooted. Well, this is my c, which is my distance, and all I would have to do is also square root that guy as well. So the distance formula is x squared minus x2 minus x1 squared plus y2 minus y1 squared square rooted, and that will get you your distance between the 2 points. So what does it look like? So we have SR, and it has an endpoint of S that is -2 and 14. And we have an R that is 3 and -1. And they want to know what is the distance to the nearest tenth. So we can call this my x1, y1. We can call this my x2, y2. So using the distance formula, we got 3 minus -2 squared plus -1 minus 14. Really? Square root. So this is the same thing as saying 3 plus 2. So this is 5 squared plus -15 squared. That gives me 25. I want to say that's 225 off the top of my head. And it is. Which gives me 250. I get the square root. And they don't want me to use radicals. They wanted it to the nearest tenth. Alright. Square root 250 gives me 15.8. So in this previous problem, I got 15.8, and I called x1, y1, and x2, y2s, these two particular things. It shouldn't matter which ones I call my x1, y1s, and my x2, y2s. So what we're going to do is we're going to do the same exact problem, but we're going to switch the x1s and the y1s. So this is now going to be x2, y2, and this is going to be x1, y1. Nothing should change. I should still get the same distance. So when I do the formula, now that this is my x2, it's going to be -2 minus 3, as opposed to 3 plus -2. And then this is going to be 14 minus -1, as opposed to -1 minus 14 squared square root. This is -5 squared plus 15 squared. This gives me 25. This gives me 225. This gives me 250. And it's still 15.8. So it doesn't matter what you call your x2, y2s, x1, y1s. As long as you have both the x's being subtracted from each other and both the y's being subtracted from each other and then squared, you should be fine. You should get the same answer. This is more of the same. So if we had to look on the number line and get the coordinates, here we have d to e, and d is 20, 20. That's convenient. So this has got it number 4. So d is 20 and 20, and e is 30 and -15. Yep, 30 and -15. So we do the distance. Let's call this x1, y1. Let's call this x2, y2. And as you get comfortable with this, you don't have to write the x1, y1s, x2, y2s. But it is good to see which is which for consistency. It kind of helps. So 30 minus 20 squared plus Negative 15 minus 20 squared square root, so this is 10 squared plus negative 35 squared, which is 100 plus a big number, 1,225, which is 1,325. They want this rounded to any nearest whatever. I'm going to assume it's going to be to the nearest. To the nearest 10 plus 100. Square root the answer. And I get approximately 36.4 meters. And again, if I was to interchange that, I would still get the same answer. So let's just do that one last time. Instead of saying 30 minus 20, I can do 20 minus 30 squared. Instead of negative 15 minus 20, I can say 20 minus negative 15 squared square root. Again, this is 10 squared. This is 35 squared. Guess what? I get the same answer. Sorry, 100 negative 10 squared. I still get 100. I still get 1225, which is 1325, which still gets me 36.4. So it doesn't matter which x's I subtracted are interchangeable, as long because we're squaring it anyway, the difference will still be the same. And you should get the same answer. Okay, so this is this section. Hope you have a great rest of your day.